Hey everyone, so I'm going to do a screencast-o-matic or a screencastify or whatever, and what it's going to do is it's going to show you my screen over here, and then it's going to show me down there in the bottom right. Alright, so this first free response question is asking you about standalone versus grid-connected systems. So there are two different types of photovoltaic or solar panel systems, and the first one is called a standalone system, and a standalone system is basically where you have just the solar panels, you have some sort of AC to DC converter, and you have a battery, and you store all the energy that you make, and you're not connected to the grid at all. And when I say the grid, I'm talking about the power lines. Alright, so grid-connected systems are systems where you have, you have the solar panels, but you also have the power lines in case you run out of electricity or something like that. And grid-connected systems also have the luxury of, if you make too much electricity from your solar panels, you can sell it back to the to the power company, and you can make some money that way. Alright, so that's what this is asking about here, and now it wants us to describe one environmental benefit and one environmental cost of photovoltaic systems. Alright, so one environmental benefit is that if we are using solar cells or solar panels, then we are not using fossil fuels for electricity. And that's a good thing because we're not going to be, putting off CO2 or any other harsh greenhouse gases. Alright, so we're not using fossil fuels for electricity. Burning fossil fuels such as coal, natural gas, or gasoline can lead to an accelerated greenhouse effect, which can cause global climate change. Alright, so that's one benefit, one environmental benefit. An environmental cost of using photovoltaic systems or using solar cells, one environmental cost is that the photovoltaic cells require a ton of energy and water to manufacture. We also have to mine for the silicon that we use in the solar cells. And then there's also the whole question of what do we do after, the solar cells, we don't want them anymore. We throw them away. Remember, there is no away. After we discard the solar panels, what happens to them? They go to a landfill. And sometimes they contain toxic heavy metals. Alright, so there's some things that you could list. Environmental benefits and environmental costs. Alright, so let's go down here to the next one. It says a family currently uses 2,500 kilowatt hours on average per month, and kilowatt hours cost $0.12 or 12 cents in Arizona. Alright, so it says calculate the current cost of the family's power bill per year. So per year, they use 2,500 kilowatt hours, and this is the abbreviation for kilowatt hours. We're going to multiply that times the 12 cents or $0.12 that they use per month. Alright, so now I'm going to use a calculator. 2,500. My calculator's being very slow for some reason. Alright, 2,500 times 0.12. Alright, that's going to be $300, and that's per month. Then we're going to multiply that times 12 months, not 12 months, 12 months, and that's going to equal basically $3,600 per year. Alright, so now, since we've got that, we've got $3,600 per year. It says if the family installs a photovoltaic system on their roof, which equals 100 square feet, and the annual production is 5.0 kilowatt hours per square feet per day, then calculate the number of kilowatt hours that this family can create in a year. Alright, so that's a lot. Alright, so it says that the total square feet is 100 square feet for the photovoltaic cells. Whoops, X that out. Alright, so since it's feet squared, we're going to multiply that times the 5.0 kilowatt hours times feet squared per day. and that's going to give us 100 times 5 is going to be 500, and the feet should cancel each other out. Alright, so 100 times 5 is 500 kilowatt hours per day, and then we're going to multiply that times the 365 days per year. Alright, equals, so 500 times 365, that's going to give me 1,825,000, let's see, 1825. Alright, so it's only 182,500 kilowatt hours per year. Alright, the solar system is only 10% efficient. That is, 10% of the solar energy is going to be transformed into useful electrical energy. So we're going to have to take the number that we just got in the previous one, and we're going to multiply it times the 0.10, because that's 10%. Alright, and you can use a calculator on this if you want. You don't really have to. So 182,500 times 0.10. That's going to give me 182 times 0.10. Is it 18250? Or 18,250 kilowatt hours per year. Alright. So now the last one, it says calculate the number of months that the family could operate the photovoltaic system without using any electricity from the grid. Assume that they use 22,500 kilowatt hours on average every month, round to the nearest whole number. Alright, so if you look here, or look back up here, they use approximately 2,500 kilowatt hours on average per month. They can generate 18,250 kilowatt hours per year. Alright, so we're going to take this number, the 2,500 kilowatt hours, and divided by the 2,000. Alright, so it's approximately 7.3 months that they can, or 7 months. Alright, so that's going to go down here for this next one. Alright, so now it says, from the two types of solar systems listed on the government website, that was the thing from earlier, the reading section. Select the system that you think best meets the needs of these homeowners. Write an argument for them to purchase the system you selected. Include the pros and cons of each system in your argument. So, since the family uses so much electricity per month, I would suggest that the family use the grid-connected solar system. The amount of electricity that they generate each year would only give them about 7 months worth of electricity. The family would need to pull electricity from the grid to make up for the loss or the rest of the year. Alright, so the pros and cons of each system. So the pros to this system would be that they can have electricity when they run out. The cons include paying a power bill or paying the electric company even though they have solar panels. The solar panels are also very expensive to install. This should say solar panels. Alright, so there's one. Alright, next one. Describe 2 ways that the government or industry could promote the use of photovoltaic power systems for homeowners in the future. Alright, so the first way is for the government to provide these things called subsidies. Alright, the government could provide subsidies. Subsidies are where the purchaser pays some of the price and the government takes up the rest of the price. So basically your tax dollars are going to pay for things like solar panels and stuff like that. So the government could provide subsidies, and this subsidies would lower the price of the photovoltaic cells and make them more affordable. Alright, what else could the government do? The government could put a tax on coal and other fossil fuels that would make the energy from fossil fuels more expensive. So if the energy from fossil fuels is more expensive, more people might be more likely to switch over from the fossil fuels to, solar panels, wind energy, and other stuff like that. All right. So letter E says, describe 2 ways that homeowners can use passive solar designs in indoor systems, and for each way explain how it will reduce the homeowner's energy cost. Alright, so if you didn't realize this, passive solar energy is where you're not using the solar panels, you're just using the natural sunlight. So like you use the natural sunlight to heat up your house in the morning, or you're using the giant blocking, like the curtains that block out the heat during the summer, and stuff like that. So the first way that the homeowners could use passive solar design would be to orient windows towards the rising sun to heat their home in the winter. The homeowners could also use blackout curtains in the summer to keep their house cooler. Since the homeowners are not using since they're not using heat or the air conditioning, then their energy usage would go down and therefore decrease their energy costs. Okay? So basically all I've done here is I've just said that, they can, use blackout curtains, they can use, passive solar designs so that they're not having to run the AC or run a fan or something or use the electricity, which would then make their energy costs go up. Alright, so now number 2 is talking about West Fremont, and it's a community consisting of 5,000 homes. Currently, a small coal-burning power plant currently supplies electricity for the town. The capacity is 12 megawatts. The average household consumes 8,000 kilowatt hours every year. The price is $10.10 or 10 cents per kilowatt hour. And the town leaders are considering a plan where they're going to bring in wind turbines. It's going to be 10 wind turbines, and that each wind turbine can do 1.2 megawatts. And it'd cost the town $3 million, and I'm assuming that's per wind turbine, and operate for 25 years. Alright, so assuming that the existing power plant can operate at a full capacity for 8,000 hours per year, how many kilowatt hours can be produced by the plant? Alright, so here's what we're going to do. The average household consumes 8,000 kilowatt hours. So that's what I'm seeing right here. The average household consumes 8,000 kilowatt hours per year. How many kilowatt hours can be produced by the plant in a year? Alright, so here's what we're going to do. We are going to do 8,000 hours per year. We're going to multiply that times 12 megawatts. Okay? And that is basically going to get us the number in 9. It's going to get us 96. Oh crap! What happened? All right, 96000, and that's going to be megawatts per year. All right. Then we're going to multiply that by 1,000 because there's 1,000 kilowatts in 1 megawatt, and that's going to get us 9.6 times 10 to the 1, 2, 3, 4, 5, 6. All right, megawatt hours, or sorry, it should be kilowatt hours per year. Okay, so now we are going to do the next one. It says, at the current rate of electricity usage per household, how many kilowatt hours does the community consume in 1 year? All right, so they consume 8,000 kilowatt hours per house. I'm sorry, it should be house. Times 5,000 houses. That's going to give me 4 times 10 to the 7th kilowatt hours. All right, so that was pretty easy. We just had to multiply how much each household uses times how many houses there are, and that gives us kilowatt hours per 1 year. Okay? All right. It says compare your answers, blah, blah, blah. Why do you not expect them to be the same? Don't expect them to be the same. I think this answer is wrong. I think this is supposed to be times 10 to the 8th. Let me use my calculator. 96000 times 1,000. Yeah, that's right. All right. Yeah, that's supposed to be times 10 to the 7th. All right, so compare your numbers and why do you not expect them to be the same? The coal-fired power plant has to supply electricity to the entire town. The calculation above assumes that all households use the same amount. Some houses may use more than others, and the coal-fired power plant has to account for that. It's better to have too much electricity than it is to have a shortage of electricity and people run out. Alright, so that was pretty easy. Alright, let's do the next one. Delete, 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 delete. Alright, assuming that the electrical energy needs of the community do not change during the 25-year lifetime of the wind turbines, what would be the cost of the community? Alright, so here's what we're going to do. We're going to multiply the amount of electricity that they use per year, which I had right here, 4 times 10 to the 7th kilowatt hours per year. I'm going to multiply that. Alright, so it's going to be 4.7 times 10 to the 7th times 25 years. Alright, because this is how much they use in 1 year, and they're going to be using it for 25 years. Alright, so when I multiply that together, so 4.7 times 10 to the 7th times 25, I get 1.175 times 10 to the 9th, basically kilowatt hours. Okay? Alright, so since this is in kilowatt hours, alright, and we want to know how much it's going to cost them if they use this many kilowatt hours, and if they want to install the wind turbines, it's going to cost them $3 million per wind turbine. So it's going to cost them 3 times 10 to the 6, which is 3 million, per turbine, times 10 turbines. That's going to be $30 million, or 3 times 10 to the 7th dollars. Alright, so now it says express your answer in dollars per kilowatt hour. What you're going to do is you are going to divide the two. You're going to do this number, the dollars, divided by the kilowatt hours. So you're going to do 1.175 times 10 to the 9th. Oh, I keep hitting the wrong button. Times 10 to the 9th. Divided by $30 million. And that's going to get you 0.0255 dollars. I'm sorry, I messed that up. I should fix it. Hold on. Alright, so I'm going to fix this one here. Let's flip-flop that. It's going to be $30 million divided by 1.175 times 10 to the 9th. That's going to give me 0.0255 dollars per kilowatt hour, or approximately $0.03 per kilowatt hour. So it's going to be about 3 cents. Alright, letter E. Identify and explain 2 environmental benefits to West Fremont switching from coal to wind power. Alright, the first benefit is going to have to do with we're not burning coal, we're not going to have this, the particulates and the air pollution that are associated with coal. Alright, the first benefit will be the reduction in air pollution, such as particulates, sulfur dioxides, and the emission of toxic heavy metals, such as lead, arsenic, and mercury that can be found in small amounts in coal. The second benefit would be that since there is no sulfur dioxide being emitted, there will be no acid rain, and the pH of soil and waterways would not decrease. Alright, so since we're not burning coal, then we're not going to have any of the sulfur dioxide, which would lead to the pH decreasing of the soil and stuff like that. So those are 2 benefits. You could have also said that, the price of electricity is going to go down, which therefore people might use more or something like that. All right, identify and explain 2 environmental costs. All right, if the wind turbines are built, large flocks of migratory birds may fly into the blades of the wind turbines and be killed. All right, the large amount of birds dying may cause a population crash for these species of birds. Alright, so the birds are going to fly into the wind turbines. That's one thing that could happen. That's one bad thing that, could be bad. Another thing is the wind turbines are notoriously known for producing noise pollution, which could disrupt animal migrations. People may find it annoying and relocate. Some people may experience higher instances of anxiety and depression. Alright, so that's pretty much it for all of these. The hardest ones on here are the math ones, learning what to do or what they're looking for. I even struggled with letter D here. I had to work it out on paper and it took me about 5 minutes. All of these are old AP questions. So if you want to, you can look up the answers. I think the West Fremont wind turbine number 2, I think it's 2004. So if you'd like, you can go on there and look up that. I hope you found this video interesting, or I hope you found it helpful. Anyways, have a great day.